Hi everyone and welcome to this Valkyrie sound tutorial. In this tutorial we'll create a turret that fires at the player. When the player's hit, we'll spawn an impact sound and a yelp. When bullets whiz past the player, we'll spawn a flyby sound. And when the player is hiding, we'll spawn an explosion when the turret hits the object that we're hiding behind. I'm using the default third-person template for this, with some extra assets in from Megascans. You can easily adapt this to the first-person template as well if you like. First, we need to set up some physical materials. This will let us identify which body parts have been hit. So, go to Project Settings, Physics, and then scroll down to the Physical Surface section. I've added some new surfaces that match the body parts we're going to use in this tutorial. So you have PM for physical material, PM_head, body, leg right, leg left, arm right, and arm left. Next, go back to the content browser and right-click, Physics, Physical Material, and then Physical Material again, and then select, name that using one of the names we've used in the project settings, and after you've done the first one you can just hit Ctrl and W to duplicate rather than having to go through those extra menus, and just rename each one. So as you can see, I've set up the physical materials using the same naming convention we've used in the project settings, and now we need to go inside each one, and this section here, physical properties, the surface type, we need to select the corresponding surface type that matches the physical material we're in, save, and we can close that. Next, we need to find the physics asset of the third person character. The easiest way is to select the third person character in the main window, and next to the skeletal mesh, there's a little magnifying glass, click on that, and then we want to open the physics asset. You'll see this sort of Michelin man here. You'll just select the body parts you want, such as the three elements for the right arm, for example. And then on the right here in the details panel, you can see physical material override. And in there, just select the appropriate material that we've already made and set up. And do that for each section. So I've grouped it by legs, by arms, by torso. That's the pelvis, spine 1 and spine 2. And the neck and the head for the head one. Next, it's time to set up sound cues for each body part. I'm using some impact sounds from my Cyberpunk City sound pack. I'm using a different impact sound depending on whereabouts on the body the character gets hit. You can find a relative cornucopia of impact sounds on freesound.org, so go and check that out. I've also added some pinned voices here. You natco and get these from the site linked in the description below. So I've set each sound cue up like this. We've got our pinned expressions going into a random node. And I've got an empty input here. Basically that means that we're not going to play a pinned expression every single time, just add a little bit of variety. That goes into a delay node with a value of 0.1 to 0.25. So it's going to offset a little bit from the impact sound, which is here. Both of those sounds go into a mixer, default settings for those, then into a modulator node, again default settings for that, and that goes into the output. So the whole effect is Now all of the random inputs have the same weighting, so there's no priority of one over the other there. And it's the same setup for each of the body parts. The only difference is that we're having a different impact sound for each one. And again, if we look at the naming conventions I've used here, it's SC impact and then the body part that it relates to for each one of these as well. And as you can see here, we also have a sound cue for bullet. This one is morbidly easy. If we open that one up, what we have is a simple projectile sound. Again, that's from my Cyberpunk City sound pack, but you can get those, a lot of them, from the freesound.org website. That goes into a modulator, again, default settings, and that's it. And finally, we have the flyby sound cue. So the flyby is that sound you get as something whips past the person's ear, or more commonly a sound that's used to represent the sound of a bullet or an arrow whizzing past the actor's head or the character's head, but that's the hyper-real sound that we get in film and in games as well. You can make these sounds very easily using your phone, just by going and then layering or pitch shifting or putting some other effects on them in free software like Audacity. Some sound designers really swear by using washers, getting an elastic band and pinging them past the front of the microphone. I'd really only recommend that, to be honest, if you're not inside. Countless damage would be done. Those sounds, I've got 3 of those just to add a little bit of variety. They're connected to a random node, again, equal weightings, and then to another modulator node, again, just using the default settings. The only other change I've made here is that by default, the volume multiplier is set to 0.75. I've raised that to 2, so the Flybys are a little bit more defined in the listening environment, and that's it. What we'll do next is set up some attenuation for the bullet. As we move further away from this turret, we want the bullet to sound quieter. For this, we right-click, go to Sounds, Sound Attenuation, and these are the settings here. So we have an inner radius of 200 and a fall-off distance of 2000. I'm sure you already know. The inner radius, this is the distance from which the sound is going to be at its maximum volume. So if we are at 100, it's going to be maximum volume, same as at 200. Between 200 and 2000, the volume is going to fall off. It's going to decrease over time in a linear line, and it's going to be 0, a volume of 0, by the time we've reached a fall-off distance of 2000. With that set up, save and close. Next, we'll go into the character blueprint. Only a couple of things to do in here. First, double check the collision settings on the mesh. We want visibility and camera set to block. Next, we'll create one variable I've called mine fizz mat sound cues. Bit of a mouthful, but what this is basically is it's going to match our physical material with a sound cue. So go to add. We change this to physical material object reference. The little icon here, the container type, we change that to a map. And then for the second type, we get a sound cue, object reference, compile that, and then we can start adding elements in here. Arm left and the appropriate arm left sound impact as well. We need an entry down here for every body part, so you should have 6 body parts and 6 corresponding sound effects as well. Last step in here is to add a sphere collision. So add component, sphere collision, and we're going to set the sphere radius to 128. And again, scroll down. For this one, we'll probably need to set the collision preset to custom, depending on what it defaults to, and make sure that visibility and camera are set to overlap. Now we're going to create our turret. In the content browser, right-click, blueprint class, and then actor. You can name that what you like. I've called mine BP turret. If we open that up, we have our default scene route, and you can see I've added a cube here, just an ordinary cube. And then to that, I've added an arrow, which I've unticked hidden in game, so we can see that. We can see what direction the turret is facing in. And I've added 2 more cubes as well, just to help give it a turret-like appearance. And notice that the arrow and the cubes are children of the main cube, so they're going to rotate and turn with the main cube. In the event graph, from the event tick, pull out and go to promote to variable. That'll give us this, and we will rename that delta time. What we have next are some collapsed nodes. So if we open that up, what we have here, this is the part that we'll make inside our event graph. So if I copy this out, so in the event graph, drag in a reference to the cube, and from that, we want to get a set world rotation node. We want to get a get world rotation node and a get world location node. We're going to connect the get world rotation to an R-interp node, which is a rotate interpolation node. That will go in as the current. And we're going to plug up the return value of that into the new rotation input of the set world rotation node. From the get world rotation node, we're going to add a find lookat rotation node. And the return value of that one is going to go into the rintip2 target. The target of the find lookat rotation node, from there we want to get actor location, this one, And into the target, we want to get the player character. Delta time, the variable we just created a moment ago, that's going to be connected to the delta time input of the interp2 node. And interp speed here, I've again promoted to a variable, which allows us to edit this, which we can do in the main window. And I've set the turn rate here to a default of 5, and I've just called this turn rate. That's the speed at which the turret is going to rotate to face the player. Higher values obviously mean a quicker rotation, low values mean slower. So to box everything up neatly, right click with everything selected and click collapse nodes. And there we are, we can double click on that, it gets us here. You'll notice though that by default the inputs and outputs won't be connected to anything. So from our set world rotation node, just drag the execution pins to each of those, and when we go back to the event graph, we'll see that we have in and out execution pins for that collapsed graph, and we can add it in up here like we've done there. So now we're going to do everything else. So first of all, we want to cast to third person character. The object is going to be get player character. We then want to set this as a variable. That means we can reference that later on without having wires going all over the place. So for that, again, promote to variable. Then we add a delay node. This is going to be our rate of fire. From the duration input, again, pull off and promote to variable. And I've set the default there to 1.25. Next, we're going to add a play sound at location node, which is this one. And the sound is going to be SC bullet, the very morbidly simple one that we created earlier. And we're also going to apply the attenuation setting here, the at bullet there. And let's just collapse that back. Nothing else is any different in there from default. The location though, we want the location to be where our turret is situated. So we want to get the world location of the cube. So drag in another reference to the cube, get world location and hook that up to the location input of the play sound location node. And from there, we're going to add a multi-line trace by channel node. The start vector for this one is going to be the get world location again. And the end vector is just going to be shuffled a little bit further along. So from the cube, if we drag out and get forward vector, the return value we're going to multiply by float, 2,500, and we're going to add together two vectors. So it's an add vector, vector plus vector node, and we're going to plug in the get world location and this output, and that goes into the end of the multi-line trace by channel. Next, from the return value of the trace node, we want to add a branch and hook that up to the execution output of that node as well. From the out hits pin, we want to add two get a copy nodes. So get, and it's get a copy. In the top one, I've defined the integer as 1, and in the lower one, I've defined the integer as 0. So when the trace hits our character, go back to look at that, it's going to hit the sphere first. So that's always going to be index 0. And because it's a multi-line trace, it'll keep going and it'll register whatever it hits next. So the player would then be the next hit item if it went straight through to hit the player. What we'll be setting up is, say it was this grey line here instead, it's going to hit the sphere and that's going to generate a flyby sound. So let's focus on the impacts on the player first. From this one, the one with the one integer in it, we're going to break the hit result. And then from hit actor, we want to drag out, hit equals twice, and we want equal object. And we're comparing that to the get player character. We want to know if the player character has been hit or not. And then we'll hook that boolean up into a new branch node and connect that to the true output of a branch node coming from the trace node. From the true output of this branch node, we're going to add a spawn sound attach node. So all the way along here. And we're going to drag in our reference to the character blueprint, the one that we created through our cast earlier. Just drag that in as a get. And then from there, we're going to get our reference to the map we made as well. So we want fizz, mat, get. From there, we want find. And this is going to find the appropriate sound for the physical material that's been hit or detected by the trace. So we would then hook that up to the sound input of the spawn sound attach node. And the input here, if we zoom out a bit, the input here is going all the way back over here to the physical material output of the break hit result. Also from the character blueprint, we want to get a reference to the mesh. So we have to scroll down a little bit for this one, get mesh, and that gets hooked up to the attached component input of the spawn sound attach node. The location is going to be linked all the way back, if we follow this yellow line, to the impact point of the break hit result node. And you can see I've split that as well for our next node. Because it wouldn't be much fun if it was just the sound on its own, we need something visual as well. This is an audio-visual medium. So what we're also going to do is, from the spawn sound attach node, we're going to add a spawn emitter at location node. The location, as I say, is going to be the same. It's going to be the impact point of our break hit result node. And I'm just going to use the default, the particle explosion. I've changed the colors a little bit so it looks nicer in the scene. And you'll see I've also scaled this as well, so it's a very small explosion. So that's our audio-visual setup for a hit against the player. So what happens if the turret misses, but it's a near miss? So if we go back to this branch here, where we were checking to see if we'd hit the player character or not, from the false output of this, if we've missed, we're going to check, okay, well if we've missed, have we still at least hit the sphere that's around the player? So to do that, we're going to come off the multi-line trace channel where we had the second out, the get node here, with the 0 index, which is detecting our sphere. We're going to pull out and add another break hit result for that. Just expand this out. We're getting the hit component this time, and this time we get another reference to our character blueprint, and from there we want to get the sphere. So get sphere, scroll down, very bottom here, and then we're comparing that to the hit component. That gets added to the branch node that we created from the false output of this branch node. And from the true output of that, we're going to add a spawn sound at location node. The location of the break hit result is going to be the location input of that node. The sound is going to be the SC Flyby that we created earlier, and we don't need to change anything else on that. But what if it's not the player and it's not the sphere, but the bullet hits somewhere else instead? Okay, so from the false output of that branch, we're going to add a spawn sound at location node again, and this time we're just going to use the standard explosion cue that comes as part of the third person example map. The location for this one though is going to be the impact point. And again, we're not doing anything with the default settings there, and we are also setting the same location. The impact point is going to be the same location input of the spawn emitter at location, the same node copied down from our if it hits section here, but scaled up, so it's 1.5 times the size, so it's a bigger explosion as it hits the rocks and the ground around the player as we run around the scene. And that's it. So if we compile and save that, and then we go back to our main screen, so let's test this out. God. Yep, that works. And we're getting our flyby sounds as well. And if we hide behind the rocks, big explosions. And do we get different sounds if we have different body parts getting hit? There's a torso. Leg, yep. Yep, different leg. Yep, has an arm. Yep. So we've set up our character to respond to different impacts depending on where on the body the character is hit. One way that we can improve the system is by using an attenuation setting on the flyby sound with spatialisation applied. Spatialisation basically allows us to position a sound in the left or right speakers, creating a more immersive experience. We can get the sounds to flick from left or right depending on where the player is looking. Now in third-person character mode, it's a bit tricky to spot that. So what we can do is, in our third-person character blueprint, we can add this setup. So from event begin play, we're going to add a set audio listener override node. First, add in the get player controller node, and then set audio listener override. That's going to be the target. Attached to component is going to be our mesh. The location is going to be a get world location node from the mesh, And you can see I've split the rotation input as well. I've done that because the Z value was flipped around the wrong way. So we are multiplying that value by -1 to flip it back in the other direction. That means that if we run around the turret with the turret on the player's right, we'll now get sounds from the right. If I don't get hit. And if we run around to the left, sounds are coming from the left. Now that's going to be much more effective if you're using mono sounds as your imported sounds for that particular Flyby asset. In this case, I'm using stereo sounds, so it's not going to have quite as good an effect. But this is just an example on how you can set the system up, and obviously you can make your own tweaks and play around with it so it works for you in your project. And that's it for this tutorial. Take care, keep making your own projects, and as always, thanks for watching.